Now that you understand variables, data types, and more complex data structures in Python, we can perform some miscellaneous operations. Here I am in a brand new notebook called Miscellaneous Operations, and I'm going to show you how copy works with simple variables and with complex data types. Let's start with a variable that holds a primitive data type such as a string. Here I have the variable name, which holds the value James, and I'm going to create a copy of James. I can do this with a simple assignment operator. Name underscore copy is equal to name. Once I've executed this code, name and name copy are now two completely separate variables. You can think of them as being different memory locations in your Python program. So if I were to update name copy to Janice, this will not affect the original name variable. So if you were to print out the values of name and name copy now, you'll find that they are different. Name is James, but name copy is Janice. So with primitive data types such as string, boolean, float, and integer, you can simply use the assignment operator, that is a single equal to create a copy of that variable. The original variable and the copy will point to different memory locations, and modifying the original will not affect the copy, and modifying the copy will not affect the original. But let's try this with a complex data type such as a list. Here is a list of countries that I have stored in the countries list variable. Now, if I try to create a copy of this countries list variable using the assignment operator, you can see on line 1 of the active code cell, I use the equal to sign to create a copy. And then I modify the element at index 1 of the copy. So I set the value at index 1 to China in all uppercase instead of China in lowercase. Now, if I were to print out the original countries list and the countries list copy, well, you can see that both have been updated. China is in uppercase in the original list as well as the copy. So if you use the assignment operator with a list, it's not actually a copy that is created. Now, here we are learning Python with Gen AI's help. Let's actually understand this using Google's Bard. I'm going to paste in the code that I have written. I tell Bard exactly how I created my copy, countries list copy equal to countries list. I've updated the element at index 1 of the copy, and when I looked at the original and the copy, both seem to have been updated. Why is this the case, and how can I fix this? Let's see what Bard has to say. And Bard's explanation is actually very clear. When you assign a list to a new variable, that's what you're doing with that countries list copy equal to countries list. You're not creating a new copy, but you're creating a new reference to the same list. So the new variable actually points to the original list. What ends up happening with the code that we've written is that we have two variables referencing the original list. Using any of these variables will update the same list. And Bard then tells you how you can actually create a deep copy of a list, where the copy and the list are independent. Now it tells you two techniques that you can use. We'll just look at the first technique using the copy.deepCopy function. And here is an example of that. Before we understand what this does, let's copy this code over and paste it into our notebook. And then we'll follow what's going on here in this code. Now, here is the same code that I got from Google Bard, and let's see what the code does. It sets up the countries list. Then on line 4, it creates a deep copy of the countries list. This deep copy is made by calling the deep copy command on the copy object. Now, this deep copy essentially creates an entirely new list with the same set of elements. Then on line 7, we update the element at index 1, that is the second element in the list, to China in uppercase, and we print out the original list and the copy. And instead of getting a valid result, I get an error. It says name error, copy is not defined. It seems like this has a problem with the copy object I reference on line 4. If you remember, we got the name error earlier when we tried to access a variable that has not been defined. So it seems like copy is not defined. How do I actually define this? I've asked Bard a follow-up question here. I tried this where this refers to the code that Bard generated for me, and I got this error, name error, copy is not defined. Now Bard has context of our previous conversation and it knows exactly what I'm talking about. My follow-up question references the conversation that we've been having with Bard on this thread. And Bard immediately realizes what the problem is. It says the copy module is not imported by default in Python, so you need to import it before you can use the copy.deepcopy function. And the way you fix this is by adding this bit of code, import copy to the beginning of your script. So to the beginning of the code cell. So let's do this and then I'll describe to you what exactly import copy does. I've added this to the very top of the code cell, and it's important that you import copy before you actually reference copy. Here I import copy on line 1 and reference copy on line 6. And now if I were to run this code, it will run perfectly. Copy.deepcopy will create a deep copy of the list, and you can see that the original countries list has UK as the second element, and the copy has the updated value China as the second element. The original and copy no longer reference the same list. We have a deep copy. Now let's understand this import statement that we've used. When you work in Python, you don't have to write the code for everything yourself. Python has many libraries or modules, as they are called, that other people have coded up for different purposes and have made available to anyone programming in Python. This is code that has been written and tested and it's there for you to use. So, why would you rewrite this code? All you have to do to be able to use these modules, external modules that others have made available, is to use the import statement. The copy module here has already been installed as a part of the Python core libraries, which means you don't need to install that library. We'll talk about installing libraries and modules a little bit later. However, you can import copy, and all of the functions and classes and other bits of code that are available as a part of this copy module are now available to you in your program. And here I've used copy.deepcopy. The import statement is a powerful way to make use of external libraries and modules available in Python. Bard has correctly told us how we can make a deep copy of our list. Now, there is another way to make a copy of a list, that is a shallow copy. And let me try and explain how this works to you. I have the original countries list defined on line 1, and on line 2, I've created a copy of the countries list by calling countrieslist.copy. This is the copy command available on the list object itself. And then once I have the copy on line 4, I update the element at index position 1 to be China in uppercase, and I print out the original list and the countries list copy. And here you might notice something interesting. Observe that the original countries list has China with only C in uppercase, but the copy has China in all uppercase. When you just look at this result, it seems like the copy was successfully created, and when we modified the copy, the original was not updated. So, why did I call this a shallow copy and not a deep copy? Well, let me show you another example. This example is almost exactly the same as the example that we've just seen, but with one subtle difference. Notice how I've defined the countries list. It contains India, China, Nepal, Bhutan, and Pakistan, but China and Nepal are in a nested list inside the outer list. And this is extremely important. I have a nested list inside the outer list, and now when I try to make a copy of the list using countries list.copy, remember I said this will create a shallow copy, and then I access the element in the nested list and I change it from China with C in uppercase to China completely in uppercase. Observe how I use the double square brackets to access the first element in the nested list. The nested list is at index position 1 in the outer list, and the first element of the nested list is at index position 0. The update has been made to the nested list, and if you print out the original list and the copy, you can see that both have been modified. Both have China in all uppercase. And this is why the dot copy command in the list is a shallow copy. If you have nested lists or nested dictionaries within the outer list, a deep copy of those nested elements will not be created when you just use the dot copy command in the list. If you truly want a deep copy, well, we know which one to use, copy.deepcopy. Here is the same example as before. The only change I've made is to line 2. Instead of calling dot copy on the countries list, I use copy.deepcopy to create a deep copy of the original countries list. And then I modify the first element in the nested list and I print out the original and the copy. Notice that the copy has been updated with China in all uppercase, but the original list remains unchanged. So the correct way to make a deep copy is to use copy.deepcopy. Now let's work with dictionaries and see how we can create a deep copy of a dictionary. Here is a dictionary with the math, English, and science scores for Alice, Bob, and Charlie. The keys here are the names of the students and the values are the dictionaries containing the three scores. Copy.deepcopy can be used to create a deep copy of dictionaries as well. Here I create a copy of the student's course using copy.deepcopy and I update Alice's math score on the copy to be 100. I've only updated the deep copy and not the original. And if you look at Alice's math scores, in the original it's still 90, but in the copy it's 100. Only the copy has been updated. Let me show you one last useful operation you can perform using lists before we move on to working with strings. Now, let's say you have a list of student names Alice, Bob, Charlie, and David, and then you have their ages. The student ages are in a separate list. The names and the ages are in the same order. So Alice is age 25, Bob 21, and so on. Now, let's say you want to represent this using a dictionary. How can you quickly do this? There is a very interesting command called the zip command that helps you with this. On line 8, notice that I use the zip function and specify the student names and student ages. The zip function will match every element in the student names list with the corresponding element in the student ages list. So it's important that the two lists are of the same length. I then pass the output of the zip function to the dict function, which will then create a dictionary with this information. So student dict will contain student names as keys and the ages will be the values in the dictionary. So if you have your data in two separate lists and you wish to create a dictionary with the matching elements, the zip function is what you'll use. Just like you can perform operations on lists, tuples, sets, and dictionaries, you can also perform operations on strings. Let's start our next demo here on Bing Chat and let's use Bing to explore some of the operations that we can perform in Python using strings. So here is my prompt. What are some operations we can perform on strings in Python? Let's see what Bing has to say. Bing tells me I can concatenate strings, I can index into strings, I can slice strings, I can compute the lengths of strings, I can do case conversion, I can split strings. So there are many operations. I'll explore some of these. The rest you can use Bing to explore on your own. First, let's take a look at string concatenation. This is something that we've seen before. You can concatenate two strings by using the plus operator. Here I have two strings, hello, comma, and then a space, and then the string world. I use the plus operator to concatenate them and store the result in the hello underscore world variable. Now, Bing Chat had listed that we can index into strings. Let's see how that is done. You can think of a string as a sequence of characters and you can use square brackets to access the individual characters in a string. Just like with lists, the index positions start at 0. So, hello world of 1 will give you the character in the second position of the list, which is just the character E. Let's see if we can assign a new character to a string sequence. I want to change the character at index 0 to be H, but this throws an error. You can ask generative AI to help you debug this error, but we've actually seen this kind of error before. Stir object does not support item assignment. We've seen a similar error when we try to assign a value to a tuple. Just like tuples, strings are immutable. Once you've created a string, you can't actually modify that string. You can access the individual characters of a string, but you cannot change the string itself. Now, you can use the multiplication operator with a string to multiply a string by the number to get the same string that many times. So, if you want a string which has hello present 5 times, you can say hello multiplied by 5, and the 5 times variable will contain the string which has hello and then a blank space after it 5 different times. This multiplication only works if you specify the string as the left operand and then integer as the right operand. Now, if you want to compute the length of a string, you can use the len function. Len and hello world will give you the number of characters in the hello world string, which happens to be 12. We know that strings can be specified in uppercase or lowercase, And you can actually convert between cases using the dot upper and dot lower functions. Both of these are functions that you invoke on strings. Hello world dot upper will convert the string in the variable hello world to uppercase and store the result in the hello world upper variable. Similarly, hello world dot lower will convert the string in hello world to lowercase and store the result in the hello world lower variable. The string in the hello world variable will not be affected. It's immutable. The operations that you perform on strings will return results, and essentially now we have hello world in uppercase and hello world in lowercase, but the original string remains unaffected. Bing had mentioned something about the ability to split strings. Let's understand that. Let's say we have a number of fruits and each fruit is separated by a comma. The fruits here are specified as a single string within double quotes. But let's say you want them as a list. You can actually use the split function on a string to split on a particular character and extract the individual strings that are separated by the character. So fruits.split on the comma will give us fruit list where every element in the fruit list is an individual fruit. The original string was split on the comma character. The first element in the fruit list is apples. The second element is space and then bananas, then space oranges, space mangoes. Because I have spaces just after the commas in the original string. If you just want the fruits but you don't want the additional spaces, you can split the original fruits string on the comma and then the space. So the comma space characters will be found in the original list, and now you can see I have apples, bananas, oranges, and mangoes with no spaces in the fruit names. If you have a list of items specified as a string, you can get the individual items in list form by using the split function and specifying the string that you want to split on. Now, you might have a string with unnecessary spaces at the beginning and end of that string. For example, one fruit, apples, contains all of these extra spaces. If you want to get rid of these extra spaces, you can use the strip function on a string. One fruit.strip will trim away all of the extra spaces. So you're left only with the string and no extra spaces at the beginning and the end. You can't really see the spaces at the end of the string here, but they do exist in the first string apples, but they don't exist in the trimmed string. Let me now show you how you can extract the individual characters of a string into separate variables. Here I have a variable called cute animal that I have assigned the string dog. There are three characters or letters in the string dog. I can actually have three variables defined on the left side of an assignment statement. ch1, ch2, ch3 equal to cute animal will assign each character from the cute animal string to each of the variables on the left hand side of the assignment statement. The variable ch1 contains the string d, ch2 contains o, and ch3 contains g. Now, because cute animal had exactly three characters, I could specify three variables on the left hand side of my assignment statement to extract the individual characters. Now, if I tried the same thing with just two variables on the left hand side of the assignment, well, this results in an error. And this particular error is kind of hard to understand. Too many values to unpack, expected to, what does this mean? When you get an obscure message like this one, generative AI can really help you. I've pasted this error into Bing and I asked Bing what this means and how do I actually fix this. Because you might encounter this error where the reason for the error may not be obvious. Now, this explanation might be a little hard to understand for a total Python newbie. You can see that this error is raised when you try to unpack more values from an iterable than there are available. The iterable here refers to the string. Anything that is a sequence, such as a tuple or a list, is an iterable because you can iterate over the individual elements of that sequence. We get this error because we were trying to extract or unpack, in Python terminology, fewer elements from the sequence than were available. There were three elements in our sequence. We only tried to extract two. And then Bing gives us a number of ways we can actually extract two elements or the first two characters. Let's explore one of these techniques. Observe that we can access the first two characters using this strange operation here, the square brackets : 2. Let's use this and understand what this means as well. The colon 2 that you see here in square brackets is what is called a slicing operation, which can be performed on any iterable. An iterable, like I said, is a list, a tuple, strings are iterables too. This colon 2 here will extract all of the elements of the sequence from 0 through 2, not inclusive of 2. This will result in only the first two characters being extracted into the variables ch1 and ch2. Let me show you a slightly different technique to accomplish the same thing. If you have three characters in a string and you want to extract only the first two, you can use the underscore as a placeholder for the third character. The underscore only means that character will be ignored. You can't access it, it's just a placeholder. But the first two characters will be available in ch1 and ch2. Since Bing Chat led us to talk about slicing operations, let's look at some more slicing operations. Here I have a variable called hello that holds the string hello world. Let's extract bits of the string. Square brackets colon 3 will extract the first three characters in the string. Here you're extracting the characters at index positions 0, 1 and 2. 3 is not included. But let's say you want to extract 1 colon 3. This will extract the characters at index positions 1 and 2. So if you specify the first index in the slicing range, the character at that index position will be included. Or you can have something like this. Hello, square brackets 3 colon and nothing after the colon. This will extract all characters starting with index position 3 to the end of the string. At index position 3, we have the second L, so we start there and go to the end of the string. At this point, we've covered most of the basics that you need to know to work with Python, and we're ready to move on to the more interesting and logical stuff. And we'll start with control flow statements here on this new notebook called control flow. With control flow statements, you can execute blocks of code based on certain conditions. So some code may be executed if a condition is true, and other code might be executed if a condition is false. Control flow statements also include loops where you can execute the same bit of code multiple times. Before we get to control flow statements, it's important to understand logical operations in Python. And logical operations deal with Boolean values. Here I have two lines of code, and these two lines look very similar, but they're different in important ways. The first line is an assignment statement. Sum underscore Boolean is a variable that I assign the value of true. In the second line of code, observe that I use the double equal to sign. The double equal to sign is a comparison statement. Here I compare whether some Boolean, the variable, has a value equal to true. So is some Boolean true? That's what the code on line 3 checks. And the result of the comparison operation that I performed using the double equal to is true. Yes, the variable some Boolean is indeed holding the value true. Let's use the comparison statement to compare something different. I want to check whether some Boolean is equal to false. Does some Boolean hold the value false? It's false because some Boolean is actually true. This comparison that we've just performed, some Boolean double equal to false, returns false because it's not true. This might be confusing at first, but you'll soon get the hang of it. Let's initialize another Boolean, a variable, which is equal to false. The code on line 1 is an assignment statement where I assign the variable another Boolean to have the value false. The code on line 3 is a comparison statement. I check to see whether another Boolean is true. And this comparison statement returns false. Another Boolean is actually false, it's not true, and that is why the comparison using the double equal to sign will return false. But if you were to use the double equal to sign and check whether another Boolean is equal to false, whether is that false? Yes, it's true that another Boolean is false. Before you move on, this is a good place to pause and make sure that you've understood the difference between the assignment operator and the comparison operator. Let's try this once again, but with a numeric value. I've assigned the variable num to be equal to 5, and I check to see whether num is indeed equal to 5 using the comparison operator. The logical value this will return is true because yes, I have assigned num the value of 5, which means it's equal to 5. Just like we have the double equal to that checks for equality, we have the not equal to, the exclamation equal to that checks for inequality. So num not equal to 5 will be false because we know that the variable num contains 5. And there are a whole host of other Boolean operators. Num greater than 3, this should return true because we know that num is equal to 5. Let's try num less than 4. This is false because we know that num is equal to 5. Let's look at another equality comparison using an operation we've not seen before, the modular operation. Num modulo 2 computes the remainder after dividing the variable num by 2. The remainder that we get when we divide 5 by 2 is 1, which is not equal to 0. That is why this particular equality comparison returns false. The variable num still contains the integer 5, and we'll see how you can combine comparison operators together using logical operations. Here I want to check whether num is greater than equal to 5 and num is less than and equal to 10. And is a logical operator that returns true if only the conditions on both sides of the and are both true. Num greater than equal to 5 and less than equal to 10 are both true. That's why this returns true. Even if one of the conditions is false, the AND logical operator will return false. Here num greater than equal to 5 is true, but num percent 2 is equal to 10 is actually false. The comparison on the right is false, which is why the entire logical operation using AND will return false. Just like the AND, we have the OR logical operator. Is num greater than equal to 6 or num less than equal to 10? Greater than equal to 6 is not true, but less than equal to 10 is true, which is why this OR operator returns true overall for the comparison. The comparison on the right side of the OR is true, on the left is false. Even if one of the operands is true, OR will return true. But if both comparisons on either side of the OR are false, well, the result will be false. Num greater than equal to 6 is false. Num less than equal to 3 is also false. Both are false, so the OR logical operation returns false. Now, with these basics out of the way, let's ask ChatGPT generate some code that will make use of control flow operations. I start here in a brand new session and I use comments to generate code. I want ChatGPT to generate code that accepts a number as input from the user. If the number is an even number, then we print out the square of the number. And ChatGPT generates some code which is absolutely spot on. What I'm going to do here is copy this code over. We won't read the explanation and we'll run this code within our Jupyter Notebook cell and understand what it does. There is some extra bit of code here that's not needed. So I'm just going to get rid of that and we look at this simple code. On line 2, we accept an input from the user and convert that to an integer. On line 5, we use an if statement, a statement that we've not encountered earlier, to check whether the input satisfies a certain condition. If is a control flow statement that checks whether a condition is true or false. If the condition is true, the block of code within the if will be executed. Here we check whether the number is even. Num percent 2 double equal to 0. Remember that is the equality comparison operator that we've studied. If this is true, then the number is indeed even. If the number is even, the code on lines 7 and 8 will be executed. Both lines of code are within the if block, and the way we know that they are within the if block is because of the indentation. Python uses indentation to indicate which block the code belongs to. On line 5, after the if condition is evaluated, we have a colon and then we have the indented block of code that belongs to the if. The code on lines 7 and 8 belong to the if block. They will only be executed if the if condition is true. Let's run this code and I'll show you how this works. First, we are prompted to enter a number. If I enter 2, this is an even number. The if condition on line 5 will be true, and that's why you see the square of 2 is 4 printed to screen. But if you try this again with the number 5, well, 5 is not an even number, so num percent 2 equal to 0 will be false and nothing is printed to screen. Because the condition is false, the code on lines 7 and 8 are not executed. Remember, that's the code within the if block. The code in the if block will only be executed if the condition that the if block evaluates is true. And you can try this with multiple values and see that that's the case. Indentation in Python code is very important. If I were to get rid of the indentation, Python will throw an error. Python sees that you have an if block but no indented code within the if block, and it knows that something is wrong. Now let's ask ChatGPT to generate some more code. We want to accept a number as an input from the user. If the number is an even number, we print the square. If the number is an odd number, we want the cube to be printed. And ChatGPT generates correct code and explanations. Let's copy the code over and understand what the code does. On line 2, we get the user input. On line 5, we have the if condition to check whether the input is even, num%2 equal to 0. We have the code within the indented if block on lines 7 and 8. If it's even, we compute the square of the number and print that out to screen. If the condition is false, the else block is executed. We have the else keyword on line 9, then the colon, and then the indented block of code that belongs to the else block. So the else block will be executed when the condition is not true. If block executed when the condition is true, else block when the condition is not true. And let's try this out. Let's enter 7 and you can see that the cube of the number is printed. The else block code was executed on lines 11 and 12. Now if you were to enter an even number, the if condition would evaluate to true and the code in the if block, that is the code on lines 7 and 8, will be executed, and we see the square of 12 is 144. Now that we know the if else block, there are different kinds of conditions we can evaluate. Here is another bit of code that I'm going to ask ChatGPT to generate. We'll ask the user to input a name. We'll check to see whether the name is present in a list of names that we have. If yes, we'll print out your application was accepted. Otherwise, we'll print out your application was rejected. Let's get the code that ChatGPT gives us. There'll be an explanation as well, but we'll actually take a look at the code as we execute it in Jupyter Notebooks. You see the ChatGPT generated a list of names of accepted applications. And then we use the input function to accept a name from the user, and we use if username in names. The in keyword can be used to check whether a particular element is present in a list. If this condition evaluates to true, we'll print out your application was accepted. Otherwise, we'll say your application was rejected. Observe how I can check for list membership using if. If the username is present, that condition will evaluate to true. Otherwise, it will be false. Let's run this bit of code. I'll specify Bob as an input. Bob is indeed present in our list of names. That's why it says your application was accepted. In keyword expects that your list element will match exactly. Here in the input, I say David, but the first D is in lowercase. This does not match David in uppercase present in our list on line 2. And that's why I get your application was rejected. Let's try some more code generation using conditions. We want ChatGPT to generate code to accept the user's age. If the user's age is in the range 20 through 65, the user is eligible for the position. Otherwise, the user is not eligible, and we want messages to be printed out accordingly. And again, for this very simple condition, ChatGPT generates perfect code. Let's copy this code over and understand what it does. On line 2, we accept the user's age, and on line 5, we perform the if check. If 20 is less than equal to user age, which is less than equal to 65, well, you are eligible for the position. The user's age is in the right range. Else we print, you're not eligible for the position. Observe how the conditional check is very intuitive to express. 20 less than equal to user age, less than equal to 65. Let's see if this works. I enter 23 and I get you're eligible for the position. Let's try this once again with an age that is outside of the range. I enter 12 and I get you're not eligible for the position. Let me show you a slightly different way you can express the same condition. You can say user age greater than equal to 20 and user age less than equal to 65. And this will perform the same conditional check as before. I suggest you run this code a few times and see how it works. Now, what if you had a more complex series of conditions that you need to check? Like this example here. We ask the student to enter marks scored in math. If the score is greater than 90, the grade is A. If it's greater than 75, the grade is B. Greater than 60, the grade is C. Otherwise, the grade is F. As you can see, there are many more conditions to evaluate here, and this is how the code looks in Python to perform such an evaluation. Let's copy this code over and see how it works. Now, for all of the code that it generates, ChatGPT will give you an explanation, as will other AI tools. However, let's run this code and see how things work. The first if condition on line 5 checks whether the math score that you've input is greater than 90, and if yes, the grade variable is set to A. And we encounter a new keyword on line 7, elif. Elif stands for else if. The elif block will be evaluated only if the first if condition is false. So if the math score is not greater than 90, then we check whether the math score is greater than 75 using elif. We assign the grade B if that's the case. Again, we have the elif on line 9. We only get there if the first two conditions are both false. There we check whether math score is greater than 60. If yes, we assign the grade C. And if all other conditions are false, we assign the grade F. I suggest you try this out on your own and see how things work. 95 will give us a grade of A. 80 will give us a grade of B. It's greater than 75. And 65 will give us a grade of C, and all other values, let's say I enter 40, that will give me a grade of F. Here we'll continue working with control flow statements, but we'll turn our attention to loops. Loops are what you'll use if you want to perform the same operation over and over again a certain number of times. For example, here is my prompt to ChatGPT. I have a list of names and I want to print the list of names out to screen one at a time. So I want to perform the same operation on each name in the list. How can I do this in Python? And you can see that ChatGPT will generate code that contains a loop. And here it happens to be a for loop. Generative AI has picked up that you need to perform the same operation over and over again, and it creates a for loop to enable you to do this. It has initialized a list of names here, Alice through Eve. Notice on line 5, we have the for loop, for name in names. The for loop will iterate over every name present in the names list. So the name variable will first take on the value Alice, then Bob, then Charlie, then David, then Eve. And for each iteration of the loop, the name will be printed out to screen. That is the code on line 6. On line 5, we have the colon at the end of the for statement, and then we have the indented block containing the lines of code within the for loop. Here we have just the one line on line 6, the print function. And when you execute this code, every name in the list will be printed out to screen one at a time. The name variable takes on the values of the different elements in the list for each iteration of the loop. There are many different variations you can use with the for loop when you're working with a list. Here I have a list of tuples, dog ages. Every element in the list is an individual tuple, and I have the ages of 4 different dogs. Notice my for loop here. I have two variables, dog, age, in dog ages. The first variable, dog, will take on the values Oba, Moje, Nemo, and Tofu. That is the first element in the tuple. The second variable, age, will take on the values 12, 8, 6, and 2. That is the second value in the tuple. And then within the for loop, I have a print statement that uses a format specifier to print out the name of the dog and the age of the dog. Let's see what the result looks like. Here I've used a for loop to iterate over the elements of the list. The elements of the list are all tuples, so I use dog, age to access the individual elements in each tuple in the list. Here is another code generation prompt I have for ChatGPT. I have a dictionary with students and their math scores. There are a total of 6 student entries in the dictionary, and I want to display the names and scores of students who have scored over 90 in math. If you observe carefully, there is a loop involved here. You want to display the names and scores of students present in that dictionary, but there is also a condition. You only want to display students who have scored over 90 in math. You should be expecting a loop and an if conditional evaluation. And that's what you get here. Let's copy this code over and understand this code. The code on lines 2 through 9 initializes the dictionary with 6 different students and their scores in math. There is the for loop on line 12. Notice that I access student scores dot items. The dot items function in a dictionary will give me all of the entries in that dictionary as a list of tuples. And then I access the student as well as the score for that student in the for loop using two different variables. Within the for loops block that is indented, the code on lines 13 and 14, I check whether the score is greater than 90, and only if this condition is true, I print out the student and the corresponding score. And here you can see the result correctly displayed. Only Alice, Charlie, and Eve scored over 90 in math. In order to really understand this bit of code, you need to know what dot items returns. When you call dictionary dot items, it gives you the dictionary items as a list of tuples. You can see the square brackets in the result. Those are the square brackets of the list. And you can see the parentheses around the individual items. Those are the tuples. Back to ChatGPT to continue learning how loops function. I want to use a for loop to print out numbers from 1 through 5. How do I do this? We understand for loops now, and this seems like a logical next thing to do with a for loop. And you can see that ChatGPT generates code which uses a range function. Let's try this code out and see how range works. So here is the same code that I copied over. Let me just run this code and you can see that 1 through 5 is printed out to screen. The range function is used very often in Python, and because this is important, let's ask ChatGPT for some help. Your prompt can be something as simple as, could you explain this range function to me? And this answer is really helpful. The range function is used to generate a sequence of numbers, and it's often used in for loops when you want to iterate over a specific range of numbers. The range function can take 1, 2, or 3 arguments. You can specify range and only the stop value, range with the start and stop value, range with the start, stop, and step values. And you have examples here as well. Let's try out some of these examples here in our Jupyter notebook. I'm going to invoke the range function and store the result in a variable. Now, my range contains a range object, and a range object can be used to generate a sequence. Here I've invoked the range function with just one input argument, that is the stop value of the range. This range will generate sequences from 0 through 9, but it will not include the value you have specified, 10. So the stop value you specify for the range function is exclusive and not inclusive. Now let's try this once again. I say range 1 through 10. This will produce values starting from 1 going through 9, but it will not include 10. 1 is the start value of the range and 10 is 1 after the end value. The end value will be 9. If you want to know the sequence of numbers that a range produces, you can simply pass that into a list function. List my range will generate a sequence from 1 through 9. The last number that we had specified in the range 10 is not included in the generated sequence. You can also pass your range into the tuple function to get the sequence in the form of a tuple, and the tuple also contains 1 through 9. The range function is most commonly used in a for loop. So you can say for I in my range, print I, and this will print out the sequence 1 through 9. The last number in the sequence 10 is not included. The range function can also be called using 3 inputs. Here I call range with 0 as the start value, 10 as the stop value, and 2 as the step value. 2, the step specified, indicates how the generated sequence will be incremented. Here, the sequence of numbers will be incremented by 2, as you can see in the output. Observe that the sequence uses increments of 2 because that's the step size that we have specified. Now, if you've forgotten why we only get numbers through 8 and why 10 is not included, well, this is something you can ask ChatGPT. I paste in the code that we've just executed and I tell ChatGPT I ran this code to print out even numbers from 0 through 10, but it only printed out numbers through 8. Can you tell me why? And ChatGPT correctly identifies that it includes 0, 2, 4, 6, and 8. 10 is not included because the range stops just before reaching the stop value. So the range is exclusive of the stop value, not inclusive. And if you want the value 10, it shows you how you can correct your code. Make sure you specify 11 as the stop value. I should give you a heads up here. This time ChatGPT got this right. When I asked ChatGPT the same question a few hours before I recorded this, well, it got things completely wrong. It kept saying there must be something else that's wrong with my code, and range should produce values through 10, even when the stop value was 10. A great time for me to remind you of this: generative AI assistants do not always get things right. It's important that you run the code and verify for yourself whether things work as expected. Python also supports looping constructs beyond for loops, and the loop that we learn now is the while loop. Now, the while loop performs the same set of operations over and over again till a certain condition is satisfied. With for loops, you know upfront how many iterations of a loop you have. With while loops, you don't know when exactly the condition will be satisfied, so the loop can run any number of times. Let's understand this with an example. I've set the end count variable to be 7 and the count variable to be 0. I have a while loop set up on line 5, which will run so long as the value of count is less than end count. And then I have a colon and then the code inside the while block, which comprises of two lines: the code on line 6 and the code on line 8. Notice the colon after the while statement and the indentation of the code, indicating that the indented code belongs to the while loops block. The code within the while block will run so long as the condition count less than n count is true. In the first iteration, count is 0, n count is 7, condition is true, so the while block will run. Now, in a while block, it's important that you update the variables that form part of the condition to ensure that the condition is false at some point in time. Otherwise, the block of code within the while loop will execute forever till the program crashes. Notice that on line 8, I've incremented count by 1. So each iteration of the loop, count will be incremented by 1 till the condition count less than n count is false. Let's run this loop and take a look. Observe that count is 0, 1 through 6 is printed out to screen. The moment count becomes 7, count less than n count is false and the loop is terminated. In a while loop, the condition that you evaluate can be anything. Here I've set n count to 0 and count to 7, and I run the while loop so long as count is greater than n count. For every iteration of the loop, so each time I loop around, I print out count and then I decrement count by 1. This is the code on line 8. Now, when I run this loop, notice that count starts at 7, it goes down to 1, and then the loop terminates. The condition count greater than end count at that point in time is not satisfied. Now, maybe you meant to print count is 0 and you're kind of confused about why count is 0 is not printed to screen. Well, you can get ChatGPT's help with this. Let's ask ChatGPT a debugging question. I use this code to count down from 7 to 0, but for some reason, 0 does not get printed. Could you debug why? So maybe you wrote some code, you expected 0 to be printed, but it hasn't, and you're not sure why. ChatGPT can help you debug. Let's see what it says. And here, notice that ChatGPT does not know the answer. According to ChatGPT, our code is perfectly accurate and 0 should indeed be printed out to screen. ChatGPT says there doesn't appear to be an issue with the code itself. The code initializes count to 7 in the while loop, and for each iteration, it prints out the value of count. If you're not seeing 0 printed, please double check your environment or the way you're running the code. There's nothing wrong with our environment. ChatGPT does not get this right. Let me ask Google Bard and see whether Google Bard gets this correct. I'm going to paste in the same prompt here on Bard. Let's see what Bard has to say. And it so happens that Bard gets this right. The reason why 0 does not get printed because the while loop will stop iterating when the condition count greater than n count is no longer met. So when count is 0, count greater than n count is not true. That condition is no longer met and the while loop terminates. And Bard gives us corrected code. Notice that it has changed the terminating condition. Instead of count greater than end count, it writes count greater than equal to end count. Let's copy this code in, run this code, and you'll see that 0 will be printed. Observe at the bottom, count is 0 is printed to screen. Bard has debugged and fixed the code for us. The difference between the two cells of code is in the terminating condition. The first code cell has count greater than end count as the terminating condition. The second code cell has count greater than equal to end count as the terminating condition. Errors of this kind are known as off by one errors, and they often occur when you use while loops. It's very important that you set up your terminating conditions carefully. Here is another kind of error that occurs often when you use while loops, and that is the infinite loop. Here my end count is 100, my count is 0. So long as count is less than equal to 100, I want to print out count and the square of count. I run this code and then it keeps looping forever. It doesn't stop and it keeps printing out stuff to screen. And the only way I can stop this is by clicking on kernel and then interrupt. Kernel interrupt will stop the execution of the Python kernel and it will essentially raise an exception and stop the execution of this code cell as well. Notice we get a keyboard interrupt error. What happened here was that I got into an infinite loop condition. The while loop refused to terminate and I had to forcibly stop the execution of the kernel in order to stop the running of this code. Let's ask ChatGPT why exactly this infinite loop occurred. For debugging issues, I make sure that my prompt is very detailed. I expected this program to print out the count and the square of the count, and for all multiples of 10 through 100, this is what I wanted to do, but the program only prints out zeros and then crashes. Could you help debug, please? And I paste in the code that I've actually written. Let's see what ChatGPT has to say here. ChatGPT correctly identifies that my code goes into an infinite loop because count starts at 0 and the condition is count less than equal to 100, but count's value never changes inside the loop. Count remains 0 inside the loop, the condition remains true, and I get an infinite loop. Here is some code that ChatGPT has given me in order to fix this. Let's copy this code over and see whether this works. The main change here is the code on line 7, count plus equal to 1. So count changes its value inside the loop. The terminating condition is count less than equal to 100. That's good. And there is the if condition where we only print values to screen if the count is a multiple of 10. And now we should get the results that we expect. We get count and the square of count for all values of count from 10 through 100, including 100. There's another way you can achieve the same result. Let me show you that. Instead of doing an if check to see whether the current value of count is divisible by 10, you can simply increment count by 10. The terminating condition is the same, count less than equal to 100. For each iteration of the loop, count will be incremented by 10, which means we'll only get values of count that are multiples of 10 and the squares of those values. Here's something you might want to do in a program. You want to execute some code till a certain condition is met, but you do not know upfront when that condition will be met or what that condition is. How would you go about it? Here is a prompt which explains our scenario. Could you ask the user to input a number? And then if that number is less than 0, we'll say goodbye. Otherwise, we'll print the square and cube of that number to screen. Now, I'd like to perform this action over and over again till the user inputs a negative number, but I haven't indicated that in my prompt. Nowhere do I say that I want to perform this action repeatedly. I don't say that the code should be in Python, but because in the current conversation with ChatGPT, we've been working in Python and asking questions about Python, ChatGPT generates code for us in Python. Now, ChatGPT has generated code for us, but here you can see that this code will be executed just once. There is no loop involved. That's because I forgot to specify that in my prompt. But the great thing about using these Gen AI tools is that you can ask a follow-up question. I'm not going to paste in all my instructions once again. Instead, I'll just ask ChatGPT, could you do this repeatedly, not just once? And ChatGPT very helpfully places my entire code within a while loop, which is exactly what I wanted. Let's copy this code over and understand what this does. The first thing to note here is that this is an infinite loop. Notice my looping condition while true. Well, this condition is always going to be true. So you might think that this while loop runs forever. Well, it doesn't. Let's understand why. Now, the first statement within the while loop is where we ask for the user input. Please enter a number, and we clearly say enter a negative number to quit. Now, if the user enters a negative number, if user input is less than 0, we print goodbye to screen and then we encounter the break statement. The break statement will break us out of the loop. When you encounter a break statement within a loop, that's a signal to Python saying stop whatever looping action you're doing and get out of the loop. Break will immediately take you to the line of code that is outside of this while loop. In our case, we have no line of code outside of the while loop, so we simply stop executing the while loop. Now, if the user input is not less than 0, then we compute the square and the cube of the number and print that out to screen. Let's run this and see how break works. When asked for a user input, I first specify a positive number 4, I get the square and the cube. Then I say 7, I get the square and the cube of 7. I say 99, I get the square and cube of 99. And then I say -4. Now the condition on line 6, if user input less than 0, will be true, which means I need to break out of the loop. Notice that goodbye is printed on screen and the loop terminates. The break statement can be used with while loops. It can also be used with for loops. It's a very useful construct that allows you to stop looping right away as soon as you encounter the break. Let's present ChatGPT with another hypothetical scenario for code generation. Could you generate code to iterate over the country names in a list? If the country name starts with an A, then I want to skip over that country. Otherwise, I want to print out the name of the country to screen in uppercase. You can see that our scenario here is a little different from what we had earlier. Here, we want to iterate over all of the elements in the list, but we want to skip over some elements and perform an action on other elements. Let's take a look at the code generated. I'm going to copy this code over and discuss the continue keyword that's used. That's something new that we haven't encountered before. Let's take a look at the code first and see what it does. We have a country names list that is initialized and then a for loop that iterates over each name in country names. If the country name starts with an uppercase A, then we go into the if block where we encounter the continue statement. Just like break, continue is a special keyword that you use within a loop. When within a loop, a continue is encountered, that particular loop is skipped over. The rest of the code in the loop after the continue statement will not be executed, which means the code on line 7, print country.upper, will not be executed for all names that start with A. Let's run this code and you can see that this is indeed the case. Canada, Brazil, Mexico, and Japan, names that do not begin with uppercase A, are printed out in uppercase, but we skip over the elements or country names that start with A. We don't break out of the loop. Australia comes first, is encountered in the first iteration. The loop skips over Australia, but it continues processing Canada, Brazil, and the other elements. Whatever you've seen of Python code so far, you have to admit that Python code is intuitive and concise. With Python, you can get a lot done by writing very little code. And another construct that helps with this, a construct that is not available in Java or C Sharp, is comprehensions. Now, let's turn to ChatGPT and ask ChatGPT what are comprehensions in Python. And here you can see that comprehensions in Python are syntactic constructs that you can use to create sequences. And sequences can be lists, sets, or even dictionaries. Comprehensions allow you to apply some kind of expression to every item in an iterable. An iterable, you know, is anything that you can iterate over with a for loop. And by applying such an expression, you can generate a new sequence. And comprehensions allow you to write very compact and readable code. Now you can see that there are three kinds of comprehensions in Python. List comprehensions are what you'll use to create lists by applying an expression to every item in an iterable. You can create dictionaries by using dictionary comprehensions, and then you can create sets by using set comprehensions. Python also supports something known as a generator comprehension, which are similar to list comprehensions, but they create generator objects that are more memory efficient. Now, in this demo, we'll explore list, set, and dictionary comprehensions. I'll leave you to explore generator comprehensions on your own. ChatGPT had output an example of a list comprehension, and that's the example that I have pasted here. Let's kind of deconstruct what's going on. Take a look at the expression on the right side of the equal to sign. Observe that the entire expression is enclosed in square brackets. This is what tells us this is a list comprehension and not a set or dictionary comprehension. A list comprehension is used to create a list. Let's see how we do this. Observe that within the list comprehension, we have a for loop for x in range 1 through 6. We know that this for loop will have x take on values 1, 2, 3, 4, 5. So all values excluding 6. This for loop inside our list comprehension will iterate over the values 1 through 5, and those values will be stored in x, and we'll compute x to the power 2. We'll compute x square to generate the squares of the numbers 1 through 5. And when you execute this code, this list comprehension will generate a list of squares 1, 4, 9, 16, and 25. A list comprehension is usually a combination of a for loop or anything that you use to iterate over a sequence, and then an expression that you use to generate values from that sequence. Here we have a for loop iterating over the sequence 1 through 5, and the expression x square generating the squares of numbers. You can use list comprehension by iterating over the items in another list. Here I have the original list numbers containing 1 through 5. And notice on line 3, I have a list comprehension where I have a for loop iterating over the elements in the numbers list and then computing the expression x square. And this list comprehension will also generate the squares of numbers 1 through 5. List comprehension can also be used to make a copy of a list using very efficient and concise syntax. Here is a list of car makes, and you can see here that we have a number of different cars. Now, if you were to actually make a copy using a for loop, this is how you'd set up the code. We've initialized a new list for a copy, car makes copy, on line 1, and then I've run a for loop on line 3, iterating over every car make in the original car makes list. And for each car make, I append that make to the car makes copy. So there is a lot of code here to create a copy. Let's confirm that when we update the copy, the original is not updated. So I set the make at index position 1 in the copy to Maruti. You can see the original list has Honda, the copy has Maruti. So we've successfully created a copy using a for loop. We have this bit of code to make a copy. Let's ask ChatGPT how we can create a copy using list comprehension. This is an example of a code conversion prompt when we want to convert code from one particular construct to another. Could you convert this code to use list comprehension? Let's see what ChatGPT has to say. And look at how easy it is. It's just one line of code. I'll copy this code over, paste it into my notebook, and let's understand what this code does. We have the square brackets, so it's list comprehension, and the result will be a list. I have a for loop iterating over each car make in the original car makes list. And the expression is simply the element itself, car underscore make. This will generate an entirely new copy of the original list. And we can confirm this by updating the element at index position 1 in the copy to be Maruti. If you print out the original list and the copy, you can see the original list still has Honda, but the copy has Maruti. Now that you know how list comprehension works, the code generation instructions that you give ChatGPT can request ChatGPT to use list comprehension. For example, could you use list comprehension to filter out the even numbers from a list of numbers? If you think about it, this requires iteration and then applying an expression to every element in the list. List comprehension should work for this. And here is the code that ChatGPT has generated. Let's paste it into our notebook and take a look. The numbers list contains the original numbers, and notice on line 3, list comprehension to filter out only the even numbers. We have the for loop for x in numbers, and we have an additional if condition for x in numbers if x% to equal to 0. Only the elements for which this if condition evaluates to true will be part of the resulting list. So only the even numbers will be included in the result. So within a list comprehension, you can use loops and you can use conditional evaluation as well. And the x next to the opening square bracket on line 3, well, that is the final expression, the number itself. So only the even numbers will be populated in this even numbers list. Now that you've understood how list comprehension works, you'll find that set comprehension and dictionary comprehensions are easy to understand. Let's copy over the example code that ChatGPT generated when it spoke about set comprehension. Let's paste this code into our notebook and see what it does. A set comprehension is used to create a new set, which is why we specify the comprehension within curly braces. Remember, sets are specified using curly braces. As usual, we have the for loop within curly braces for x in, and the list is specified right there, not in a separate variable. The list contains 1, 2, 3, 4, and 5, and there are a few duplicates. Notice the if condition evaluating whether this is an even number. If x% 2 is equal to 0, then it's even. When the condition is true, that's when the number will be included in the generated set. And executing this code will give us an even set that just contains 2 and 4. Because this is a set, there are no duplicates, and our condition if x% 2 equal to 0 got rid of odd numbers. You can direct ChatGPT to perform a task using set comprehension as well. For example, here I have my prompt. I have a list of countries with duplicates. Can you use set comprehension? Give me a set of countries with their names in all uppercase. And here is the code and the corresponding explanation. We won't look at the explanation. Let's copy this code over and I'll explain what exactly it does. Here is the original list of countries. Notice that the countries USA and Canada are both present twice with different casing. We have our set comprehension on line 3. The comprehension is defined within curly braces for a set. So for country in countries, we want country.upper, the name of the country in uppercase. And this simple bit of code will give us all countries with no duplicates with their names in uppercase. Now, with all comprehensions, you can have nested loops as well. Let me show you an example. Let's say you have a list of names and these individuals belong to different departments. So you have a list of departments as well. Now, let's say you want to combine the two. You want to associate each name with the corresponding department that the person belongs to. Here is a list comprehension that will allow you to do that. First, let's understand the rightmost for loop. For department in departments will iterates over every department in the department list. This for loop is actually nested within an outer for loop which iterates over each name. So for each name, we'll iterate over each department. So for the first time in the outer for loop, when name is James, the inner for loop will iterate over engineering, operations, sales, marketing. Then when name becomes Julie, once again, the inner for loop will iterate over engineering, operations, sales, and marketing, and so on for each name. In this list comprehension, for every name department pair, I create a tuple name, comma, department. Let's see what this combined list looks like. Now, this doesn't give us exactly what we want. Observe that James is now associated with all 4 departments. Julie is associated with all 4 departments as well, as is Greg and Sarah. Well, this is not exactly what I was looking for. So let me tweak my list comprehension just a bit. This time I have just a single for loop, but I iterate over the zip of names and departments. If you remember the zip function, it will match every element from the names list with the corresponding element in the departments list. The for loop will access the name and department from the list and we'll create a tuple name, comma, department. And this result will be what we want. This generates a list with tuples as elements, and each tuple has the name and the department the person belongs to. Let me show you an example of how dictionary comprehension works before we move on to other topics. Here is a dictionary that I have set up, name and the corresponding salary. There are four entries here in this dictionary, and I'm going to use dictionary comprehension to flip the entries around. Currently, the name is the key and the salary is the value. I'm going to flip it around so that the salary becomes the key and the name becomes the value for each entry. The dictionary comprehension on line 8 does this. I iterate over the keys and values in original dot items. Remember, dot items gives me the dictionary entries as tuples, and I access the key and the value in the for loop. And then I flip them around. I construct a new dictionary with value colon key. And when you run this code, you'll see the flipped dictionary. All of the salaries that were values before have now become keys, and all of the names that were keys before have now become values. At this point, we've gained sufficient proficiency in Python to allow us to move forward to a more interesting and a little more complex topic, working with functions. A function can be thought of as a reusable block of code that performs a specific task or set of tasks. By organizing your code into functions, you can avoid repetition, make your code readable, and simplify complex operations and achieve modularity in your code. Let's see how we can write a function in Python. I'm here on a new session on ChatGPT, and I'm going to ask it to define a simple function that prints out hello to screen. I specify Python because in this new session, ChatGPT may not know I'm talking about Python here for code generation. And my Gen AI assistant has obliged, let me copy this function over and paste it into the code cell on a brand new notebook. This is how you define a function. The def keyword indicates to Python this is a new function. Say hello is the name of the function. Functions are always followed by parentheses. So I have the open close parenthesis there. The fact that I have nothing within parentheses indicates that this function does not take in any input argument. So you can't pass data to this function. The colon indicates that after this function definition comes the code within the function. Notice that it's indented just like with if blocks and while blocks, and all this function does is print hello to screen. When you execute this code, you've only defined the function. The function code runs when you actually invoke the function, and here is ChatGPT generated code for actually invoking that function. Let's paste that into the next code cell. I invoke say hello, and hello is printed out to screen. This first function does not take in any input arguments. It does not return any values as well. If you try to store what say hello returns in a variable, let's say the variable is called result, this variable will actually not hold anything. Hello is printed out to screen because we invoke the function, and if you were to print out what's in the result variable, you'll see that it's none. There is no value in the result variable because say hello does not return anything. Once you're working with functions, you can use a very interesting prompting technique to generate the code for your functions. Notice my prompt here. All I have is the function signature. The function signature is the name of the function and the input arguments that it takes in. Now, my function name is meaningful. I say return underscore hello, and this is what clues ChatGPT in as to what exactly I want the function to do. And this is all I need to specify in the prompt, and ChatGPT will interpret this correctly and generate a return hello function for me. I'll just copy this over. I just need the function definition for now. So I delete the remaining code, and let's take a look at this return hello. The open close parenthesis tells me that return hello does not take in any input arguments, but it returns the string hello. The return keyword is what you use to return values from functions. Now, when you invoke return hello, it will actually return the string hello that you can store in a variable such as message. When you execute this code, the variable message will contain the string hello that was returned from the return hello function. When I'm writing code for my own projects, I find myself using this function prompt very, very often. The prompt itself is very concise. It forces me to name my functions in a meaningful way, and this little prompt is enough to get the right response from the model. Here, I want ChatGPT to generate a function that sums up two numbers. So def sum two numbers, open close parenthesis, colon is my function prompt. Now I haven't specified that this function should take in any input argument. I have an empty pair of parentheses. But even then, ChatGPT correctly understands this and defines a function with input arguments. Let's copy this code over and understand what this code does. Within the parenthesis, I've defined two input arguments, num1 and num2. They are referred to as input arguments or input parameters because this is what will contain the data that the function operates on. Now, num1 and num2 will have values when we invoke the function, and the return value from this function will simply return the sum of the two, return num1 plus num2. Let's head back to ChatGPT and copy over the code to invoke this function and print out the result. The code on line 2 of the current code cell invokes sum two numbers and we pass in two input arguments, 5 and 7. The num1 variable will have the value 5 and num2 will have the value 7 when the function is invoked, and the result num1 plus num2 will be stored in the result variable. And when we print out the result, we'll be able to see this. All our functions so far have had just one line of code. You can have as many lines of code as you want in a function. Here, within the sum two numbers function, I've stored the sum of num1 and num2 in the result variable and I return result. This function will work the same way as the previous one. Now, if your function has two input arguments, you have to invoke it with two arguments. Here I call sum two numbers and I do not specify any input arguments, and you can see that this results in an error, missing two required positional arguments num1 and num2. Let's try invoking the same function once again, but this time I'll provide three input arguments instead of two. 5, 8.8, and 7. The function defined just two input arguments. I've specified 3, and this also results in an error. It takes two positional arguments, but 3 were given. You have to invoke a function with as many input arguments as it requires. Now, let me show you something interesting about functions. Here, I define a function called divide that takes in two input arguments, numerator and denominator, but it returns the numerator divided by 0. Dividing by 0 is an error in Python. When I actually define this function, there'll be no error in my code. The error will only show up when I invoke this function. Notice when I try to divide 3 by 4, I get the 0 division error. The code within a function block, for example, the return numerator divided by 0, is not executed till you invoke the function. So if you have errors in your function, you'll only figure those out once you invoke that function. Let's get ChatGPT to generate a slightly more complex function. Once again, I specify the function signature, def find factors. I haven't specified what input this particular function should take, but ChatGPT interprets this simple function correctly. Let's copy the code over and understand what this code does. The find factors function accepts an integer number as an input argument and finds all of the factors of that number. The factors are stored in a list called factors. There is a for loop defined on line 3 to iterate over all of the numbers starting from 1 up to and including the number itself. For every value I in the for loop, we check to see whether number modulo I is equal to 0, whether the number is divisible by I. If yes, then I is added to the factors list. And finally, on line 6 outside of the for loop, we return the factors found for this number. Before we do anything else, let's invoke this function and make sure that it works. I'm going to call find factors and pass in 12 as an input argument, and I should get all of the factors of 12 in the form of a list, that is, the return value from the function. As your functions become more complex, it's important that you document your functions so that anyone reading your code knows what that function does. Let's ask ChatGPT how you can document this function, and ChatGPT gives you in the response the same function but this time with documentation. Let's see how we actually document a Python function. I'm going to copy this code over and replace my current find factors function with the function that has documentation. When you document a function, you should specify what its input arguments are, what it returns, and what the function does. The documentation for this function is a multi-line string that have enclosed in triple quotes. You can see the start of the triple quotes on line 2 and it ends on line 14. The documentation indicates what the function does, the arguments passed in, the type of the argument, that it should be an integer, what the function returns, and an example of how the function can be invoked. And then we have the actual code for the function. We haven't changed what the function does, but we've added some meaningful documentation. Now, let me show you what exactly a function is in Python. Let's say you simply type in the function name within a code cell and hit Shift Enter. You're not invoking the function, instead, you're viewing what a function is. And a function in Python is just an object. You can see the details of the object printed out here on a screen, but a function is an object just like other objects like strings, numeric objects, dictionaries, lists, and so on. Just like objects have properties, a function also has properties. If you print out the underscore underscore doc underscore underscore property of a function, you'll be able to see the documentation associated with that function. Or you can pass in the function object to the help function, and this will print out the documentation as well. So it's important that you document your function so that other users of your function can use help to figure out what your function does. In this demo, we'll understand how positional arguments and keyword arguments work in Python functions. But before we get there, let me ask ChatGPT to generate a function for me. I've asked it to generate and document this function called create employee record. I've specified the signature of the function along with the input arguments that the function takes in. Create employee record will return the record for one employee. And I'm going to copy this code over, paste it into our Jupyter notebook, and we'll see what the code looks like. Here is the create employee record function. It takes in several input arguments, in fact, six: ID, name, salary, department, whether the employee is active, and the committees the employee is on. ChatGPT has correctly documented the types of the different input arguments specified on lines 6 through 11, and what this function returns is a dictionary representing the employee record. You can see the employee record dictionary that is created on lines 22 through 29, and this is the employee record that is returned from this function. When you have to invoke a function with so many input arguments, it's kind of hard to get the order of the arguments right. Here, I'm creating an employee record for Jackson, and I've specified all of the input arguments, and it seems like I got the order right. Jackson is in the promotions committee and the diversity and inclusion committee is active. Department sales, salary 89,000, name Jackson Thodi, ID 101. Because Python uses dynamic types, it's very easy to get the order of the input arguments wrong. Here I have salary as the second input argument, name as the third, committees as the second to last, and you can see that my employee record is completely wrong. Salary is Lara Croft, name is 96,000. Now, this mistake is easy to make because Python does not have any type checking. Also, when you look at the function signature on line 1 of this code cell, it's hard to see what type of data should be passed into each input argument, whether it's an integer or a string or a list. It's hard to see this. Is ID a string or an integer? Is salary a floating point or an integer? Is active Boolean? It's hard to see all of this. Let's ask ChatGPT if there is a way to indicate the types of the variables passed in to functions. And it turns out that in recent versions of Python, there indeed is. It's kind of hard to see this code because there is so much there. I'm just going to copy this code over, get rid of all of the documentation so that only the function remains, so that we can focus on the function itself. First thing to notice is line 1, where we import dict and list from the typing module. This is one of the built-in modules available in Python. You can see my function signature defined on lines 3 through 10. Observe that every input argument has a corresponding data type that is specified. This makes it very clear to someone using this function what kind of data to pass in. For example, on line 9, you can see the committee's input argument requires a list of strings. After the closing parenthesis of the input arguments on line 10, you can see the arrow and then dict stir comma any indicates that this function returns a dictionary where the keys are strings and the values can be any kind of object. This type specification available in recent versions of Python make it very easy for users that invoke your functions. However, these type specifications are not enforced. Here I instantiate the Lara record by invoking create employee record, but I pass in all of the wrong types. Notice name is 96,000 and salary is Lara Croft. And observe there was no error. The type specification that you see in Python is only a hint to users, it's not actually enforced. And this actually makes working with functions with a lot of input arguments hard. It's very easy to forget an input argument and get an error such as this one. I specified only 5 input arguments instead of the 6 that were needed. I missed the required positional argument committees and I got an error. It's pretty clear when you invoke functions with a large number of input arguments, using just the position to specify input arguments is very error prone. So, what can you use instead? You can use named arguments or keyword arguments. Here I invoke the create employee record function and I pass in arguments by name. Notice ID equal to 102, name is Lara Croft, salary is 96,000, committees is cultural, and so on. Here I indicate what value each of the input arguments is associated with, and my function has set up this record correctly. When you invoke functions with a large number of input arguments, it's often very useful to name input arguments when you invoke the function. Another advantage of using named input arguments or keyword arguments, as they are called in Python, is that you can specify the arguments in any order. Here I call create employee record to create the Melissa record. Notice that I pass in the value for committees first, committees equal to promotions, then name, then salary, then active, then department, and then finally ID. The input arguments are not specified in the order they've been defined in the function signature. With keyword arguments, this is possible, and you can see that the Melissa record has been created correctly thanks to the use of keyword arguments. There, the position does not matter. You just have to specify the right value for the right input argument. In fact, you can invoke functions by mixing and matching positional arguments and keyword arguments. Here, when I create the nick record, the first 3 arguments on lines 2 through 4 are provided based on position. 202, that's the ID, Nick Kruglik, that's the name, 81,000, that's the salary. The remaining arguments, department, active, and committees, I specify using the name. Department is marketing, active is true, committees is the diversity and inclusion committee. And this is perfectly valid, and you can see that the nick record has been created successfully. When you're specifying input arguments using position and keyword, you cannot specify the keyword arguments first. Python won't be able to understand what's going on. Here, if I try to run this code, you can see the error positional argument follows keyword argument. That's simply not accepted. So, if you're mixing and matching positional arguments and keyword arguments during function invocation, specify the positional arguments first and then the keyword arguments. Now, often when functions have a large number of input arguments, you may want to specify default values for certain arguments, like I have done here. Notice that the input arguments active and committees have default values. Active, which is a boolean, is true by default. Committees, which is a list of strings, is an empty string by default. There is no real change to the other code here in this function. Now, if you have default values, when you invoke the function, it's not really necessary for you to specify a value for the input arguments that have defaults. Here I invoke create employee record and only specify the ID, name, salary, and department. I haven't specified a value for active and committees. Those input arguments will take on default values, and you can see that Melissa is active, active is true, and committees is just the empty list. If you do specify a value for an input argument that has a default, the value that you specified takes precedence. Here I call create employee record. The first 4 input arguments defined on lines 2 through 5 are ID, name, salary, and department. The fifth input argument on line 6, that is whether the employee is active. I've set active to false. And you can see that in the resulting record, active is equal to false. The default value for active was true, but because I explicitly passed in false, active is false. While invoking a function, you can skip specifying values for input arguments that have defaults configured, but for input arguments which do not have defaults, you have to specify values for them. Here I invoke this create employee record function, but I haven't specified a department nor have I specified salary. But I do have active to true and committees to promotions. But this throws an error because we are missing two required positional arguments, department and salary. They do not have default values. You have to pass values for them when you invoke the function. You might have heard that Python is called a functional programming language, and in this demo, we'll understand what this means. In fact, we'll ask Bard what this means. What does it mean when Python is called a functional programming language? Let's see what Bard has to say. Here it gives you a definition of functional programming, a programming paradigm that focuses on the use of pure functions, where a pure function is a function with no side effects. And for the same input, the function always returns the same output. A pure function will not modify any data that you pass in to the function. For example, let's say you pass in a dictionary, it won't add any keys, it won't update any values. Instead, it'll return a new dictionary with the updated information that you want. But what really makes Python a functional programming language is the fact that its functions are first class functions or first class citizens. This means that they can be treated just like any other object in the language, just like strings or numbers or any other object. This means you can store function objects in variables. You can pass functions in as input arguments to other functions. Functions can be returned as return values from other functions. There are a bunch of other details here, but we'll focus on this first fact. Functions are first class citizens and they are objects that can be treated like any other objects. Let's see how this works when you actually use functions in code. Here I am on a new Jupyter notebook called first class functions and lambdas. I'm going to define a function here called isStrongPassword that takes in a password as an input argument and performs a few checks to see whether this password is a strong one. Let's quickly see what the checks are on lines 11 and 12. I check the length of the password. If it's less than 8, then I return false. That's not a strong password. It has to be at least 8. On lines 14 and 15, I check to see whether there is at least one uppercase letter in the password. We test this using the any function, which will check if there is at least one instance that's true and a comprehension. C.isUpper for C in password will check for the presence of at least one uppercase letter in the password. Similarly, on line 17 and 18, I check to see whether the password has at least one lowercase letter. On lines 20 and 21, I check to see whether there's at least a single digit in the password using C.isDigit, which will return true if the character is a digit. And finally, on lines 23 and 24, we check for the presence of at least one special character. If a special character is not present, we return false. And finally, if all checks pass, on line 26, we return true. This is a valid password, a strong password. Any function that you define in Python is actually a function object. If you just type out is strong password, you can see the details of this object. We already know how to invoke this function. We call is strong password with parenthesis and we pass in an input argument. The input argument is just password and this is clearly not a strong password. That's why we get false as the return value. Let's invoke this function on a strong password. I pass in password 1234 and a special character hash, and this will now return true. Now, let me show you how functions can be assigned to variables. So, I can take the variable validate password that's on the left hand side of the assignment and I assign it the function object is strong password. I can now use the validate password variable to invoke the function. Validate password with parenthesis, pass the strong password in, and you can see that validate password returns true. Validate password just holds a reference to the original function object is strong password. And you can actually confirm this by printing out the contents of validate password. The contents are the same as the contents of is strong password. They both reference the same object. So you can see how we can assign functions to variables just like other objects in Python. Now let's see how we can pass in functions as input arguments to other functions. In order to do that, I'm going to define four different arithmetic operators: add, subtract, multiply, and divide. Each of these functions take in two input arguments and perform the corresponding arithmetic operation: addition, subtraction, multiplication, and division. Now I'm going to define a function that takes in another function as an input argument. Do math takes in two operands, a and b, and then a math function. And within do math, I simply invoke the math function on the inputs a and b. This is the code on line 2. Because do math accepts another function as an input argument, it is a higher order function. Now let's see how you would invoke do math. You'd pass in two operands, 2 and 3 in this case, and you'd pass in a function as a third input argument. If you pass an add, do math will perform the addition, and we get 2 plus 3 in the result. Notice how I pass in the add function. I don't invoke it. There are no parentheses after add. Instead, I pass in the function object. That is just the name of the function add. Let's say you pass in a different function. Here I call do math, and I pass in subtract as the third input argument for the math function, and this performs the subtraction operation. 12 minus 23.3 is minus 11.3. And in exactly the same manner, you can have the do math function perform multiplication and division by passing in the right function objects. When you pass in multiply, multiplication is performed, and when you pass in divide, the division operation is performed. We've seen that functions can be passed in as input arguments to other functions, but what about functions as return values? Let's ask ChatGPT to generate some code for us. Here I am in a new conversation session with ChatGPT. So I tell ChatGPT my current scenario. I have several arithmetic functions defined: add, subtract, multiply, and divide. Could you write a function that takes in the arithmetic operation plus, minus, asterisk, and forward slash and return the right function? I'm expecting ChatGPT to correctly map plus to add, minus to subtract, asterisk to multiply, and forward slash to divide. Let's see if it does that. And you can see that it does. What I'll do now is copy the code over, only the code that I need, get arithmetic function. I'll paste it into our Jupyter notebook, and let's take a look at what this code does. Get arithmetic function takes in a single input argument, that is an operator. The operator can be one of plus, minus, asterisk, or forward slash. There is an operations dictionary that maps the operator to the right function object. Plus is mapped to add, that is the add function object, minus to subtract, asterisk to multiply, and forward slash to divide. These are all functions that we previously defined. Notice that function objects can be stored in dictionaries just like other objects in Python. So, just like you can store strings, numeric values, lists, etc., in dictionaries, you can also store function objects as values in dictionaries. Another indicator that functions are first class citizens. Well, when we invoke this function, we pass the operator in, we have the operations dictionary, and then we check to see whether the operator passed in is present as a key in the dictionary. If operator in operations performs this check. If the operator is indeed present in the dictionary, we access the function object associated with that operator. We do that by using square brackets on line 10, and we return that function object. If the operator was not found, we raise a value error, invalid operator. This raise value error that you see here will throw an error or an exception, and that will just stop the execution of our code. Now that we have this function defined, let's see how we can use this function. I call get arithmetic function with the plus sign, and I store the returned function object in the fn variable. And you can see that this now contains add function that we had defined earlier. Now that we have the function object, we can invoke the function to add two numbers, and we have 134.3, which is the sum of 44.3 and 90. Let's use get arithmetic function to get the multiply function. We pass in the asterisk, the function object that's returned, is the multiply function. Let's invoke this function and this will multiply the two input arguments that we've passed in. Now, if you try invoking get arithmetic function and pass invalid operator, let's say the ampersand sign, well, we get the value error, invalid operator. Now that we've understood how first class functions work in Python, let's turn our attention to lambdas. Here I am writing code in the same notebook, first class functions and lambdas. I'm going to write a very simple function first, which will simply increment the value that you pass in. So when you pass in x, it will return x plus 1. We know that this function is actually an object. So if you simply type out the name of the function, you'll be able to see the details of that function. The one thing to note here is that the function that we've defined has a name and the name is increment, as you can see from the output. Let's invoke this function and pass in the value 4, and this should return the value 5. You can see that increment simply increments the input argument by 1. I pass in 9.9 to the increment function and this returns 10.9. Now, so far, all of the functions that we've defined have a name. For example, this increment function that we've just defined has a name, increment. Lambdas in Python are anonymous functions that do not have a name. They're usually single expression functions, meaning lambdas in their body contain just one line of code. I've switched over to ChatGPT and I'm going to ask ChatGPT to rewrite this increment function as a lambda. Can you please write this function as a lambda? Please call it plus 1. And ChatGPT quickly generates a lambda function for me. I'll just copy this code and then paste it into our notebook, and then we'll understand what exactly this lambda function is and how we can work with lambdas. A lambda is a single expression function and it's defined using the lambda keyword. Here I've assigned a lambda function to the variable plus 1. Plus 1 is on the left hand side of the assignment statement. On the right hand side, we have the lambda. I have the lambda keyword and then the input argument that the lambda takes, which I represent using the variable x. And then we have the colon, and after the colon, we have the single expression that makes up the body of the lambda. So the only expression within the body of the lambda is x plus 1. X references the input argument, increments it by 1, and that is what the lambda returns. This is actually a function with no name. Plus 1 is the variable that we use to reference the lambda, and if you print out the details of plus 1, notice that it's a function, but the name simply says lambda. The lambda is anonymous. Once you've defined a lambda and assigned it to a variable, you can use that variable to invoke that lambda function. Here I call plus 1 and pass in 6. The lambda increments the input argument by 1 and returns 7. Let's try this once again. I invoke plus 1 and I pass in 101.3 and the lambda returns 102.3. The input has been incremented by 1. Let's define another lambda, this time to perform multiplication. Notice the lambda keyword. You have to use that to define a lambda. A is the input argument passed to the lambda. Then we have colon and then the body of the lambda function. The body simply has the single expression a multiplied by 10. Any input that you pass into the lambda, the return value will have that input multiplied by 10. Now, this lambda is stored in the multiply by 10 variable, and you can use this variable to invoke the lambda function. Let's multiply 23 by 10, and the lambda returns 230. Let's try this once again. I'll multiply 1.567 by 10, and the lambda will return 15.67. Now, if you remember, earlier in this notebook, we defined a do math function that takes in another function as an input argument and invokes that function on the two operands that are passed in. So math function is an input argument that is a function to do math. I'm curious whether lambdas are treated just like other functions. So I turn to ChatGPT. I have this function that accepts a function as an input argument, and there is the definition of our do math function. Can I pass in a lambda as a value for math underscore function? And ChatGPT is quite sure that we can. Lambda functions are just anonymous functions in Python and they can be used wherever you need a function. And ChatGPT also gives me some example code that I'm going to copy over and paste into our Jupyter notebook. You can see that ChatGPT has correctly figured out the right signature for the Lambda function that we can use with do math. On line 2, we have the add Lambda, which is a Lambda function that takes in two input arguments, x and y. And then we have the colon and then the body of the function, where we simply compute x plus y. Lambda functions can only have a single expression within their body. So you can only have one line of code. On line 5, we invoke the do math function, pass in input arguments 5, 3 and the add lambda. We store the result in the result variable and print that out. And you can see that 5 plus 3 is equal to 8. So far, we've been defining Lambda functions and storing them in variables, but really, you don't need a variable to store your Lambda in. You can directly pass the Lambda in as an input argument to do math. Here I invoke do math. 45 is the first input argument, 23 the second, and the third, the math function, is the Lambda that I have defined. The Lambda takes in two input arguments, a comma b, and then computes a divided by b. And when you invoke do math by passing in this lambda function, what you'll get is the result of 45 divided by 23, which is 1.95. Let's try this again with a different lambda. The lambda takes an a comma b and computes a minus b. So when we pass in 4 and 55, we get minus 51. Let's try this once again. I'm going to invoke do math and pass in a lambda that computes a to the power b. I've passed in 4 and 55, so I get 4 to the power 55, which is that very large number you see on screen. Let's explore this world of lambdas further, and I'm going to turn to ChatGPT for some help. What are some Python functions that accept lambdas as inputs? Given how useful lambdas seem, they have to be built-in functions that take in lambdas. Let's see what they are. Now, the first function that ChatGPT has suggested to me is the filter function. The filter function is a built-in function in Python used to filter elements from an iterable. Remember, an iterable is just a sequence. And the filtering is based on the lambda function that you specify. Let's copy this bit of code over and see what it does. There is a list of numbers here on line 1, and I use the filter function to filter out the even numbers in this list. The filter function takes in a lambda as an input argument. Notice the first input argument, the lambda takes in x and checks to see whether x% 2 is equal to 0. If x is even, x% 2 equal to 0 will return true, otherwise it will return false. The filter function will invoke this lambda on every element in the numbers list. Every element that returns true will be included in the result. Each element that returns false will not be included in the result. So the lambda will be invoked on each element of numbers 1, 2, 3, 4, 5, and 6. The filter function returns a filter object stored in even numbers, and we can pass in even numbers to the list function and print out the resulting list. The even numbers in our original sequence are 2, 4, and 6. Just a note about how filter works. Filter selects only those items from the original list where the lambda expression that you've specified evaluates to true. Let's go back to ChatGPT's response and see what other functions accept lambdas. Another function seems to be the map function. Let me copy this code over and we'll see what it does. The map function applies the lambda that you pass in to every element of the sequence or iterable that you've also passed in. Here we have a numbers list containing elements 1 through 5, and then I invoke the map function. The first input argument to map is a lambda specifying what transformation you want to apply to the original numbers. The lambda that's defined here takes in an input argument x and computes the square of x to the power 2. Now, this lambda will be applied to every element in the numbers list. Numbers we pass in as the second input argument. Now, once we apply this lambda to each element of numbers, we get the square of these numbers in the result. The map function returns a map object that can be used to generate a sequence. You can pass in the map object to list or tuple to get the results in the form of a list or a tuple. And here is the list of squares that you can see here on screen. The lambda expression has been applied to each element in the input list, and we now have a list with the squares of the original elements.